Today I'm gonna be talking about another approach for another way of using contrastive learning. So this paper in 2023, which is contrastive training improves zero-shot classification. Of course, contrastive training can improve anything: zero-shot learning, few-shot learning, any NLP task, because originally for the first time it was introduced for the computer vision in the context of self-supervised learning, but you can also use it for supervised contrastive learning. Not just self-supervised, you can use it for supervised, and not just computer vision, you can use it for NLP task. But of course, data augmentation for NLP is very limited in comparison to computer vision, because in NLP we, for example, use drop masking and those techniques, but in computer vision we can have many techniques like transformation and So what are semi-structured documents? Textual information assumes many forms ranging from unstructured to semi-structured, all the way to fully structured. So our focus in this work is classification of semi-structured documents. A semi-structured document consists of information that is organized using regular visual layouts and includes tables, forms, and multi-columns. So methods for unstructured document classification, such as static words and standard pre-trained language models, perform poorly with semi-structured inputs, as they model text in a one-dimensional space and ignore information about document layout and style. For example, this could be a kind of semi-structured data. Or another example for semi-structured data. So we investigate semi-structured document classification in a zero-shot setting. Classification of semi-structured document is more challenging than that of standard unstructured document. The standard classification setting, where categories are fixed during both training and testing, falls short in dynamic environments where new document categories could potentially emerge. We focus exclusively on the zero-shot setting, where inference is done on new unseen classes. To address this task, we propose a matching-based approach that relies on a pairwise contrastive objective for both pre-training and fine-tuning. And we use two encoders to account for this difference: a document encoder suitable for semi-structured documents and a label encoder suitable for natural language representation of class labels. And phi of label is just a pre-trained BERT-based model. And layout BERT is a six-layer transformer based on BERT-based and is pre-trained because the original BERT has 12 layers, but here we use layout BERT, which is just 6 layers. And transformer based on BERT-based and is pre-trained using masked language modeling on a large collection of semi-structured documents. Unlike prior work, layout BERT has a simpler architecture that decreases model footprint while maintaining accuracy. And specifically, there are three main architectural differences between the layout and layout LM. Phi label and phi document are models that have been pre-trained independently To encourage these models to produce similar representations for documents and their labels, we continue pre-training phi of label and phi of document via an unsupervised procedure based on a pairwise contrastive objective. The unsupervised objective can learn from large amounts of unlabeled semi-structured documents. Since we do not assume access to ground truth labels for this step, our pre-training procedure relies solely on self-supervision via pseudo-labels. These pseudo-labels are generated by sampling a continuous block of tokens from a document with a length drawn from a shifted geometric distribution. So B here is a training batch consisting of training documents, D and their pseudo labels. And phi of document and phi of label are just the encoders for document and label. We start by encoding each document and pseudo labeling the batch and then computing a matching matrix of pairwise dot product between every document label pair. So our objective is to increase the value of diagonal elements where I is equal to j as compared to all other elements. And the loss function for a batch is a symmetric loss. This symmetric loss, which is a loss of row and loss of column, these are per batch row-wise and column-wise losses. And for the supervised zero-shot setting, we fine-tune the model using the same objective as the pre-trained step, except that the labels for a batch are ground truth labels and not pseudo labels. The current work is an initial attempt to studying the problem of zero-shot classification. There are two key aspects that these are limitations. First, we choose layout BERT as our document encoder. This work does not experiment with the variety of encoding strategies in the literature that combine textual, visual, and layout information. It is likely that richer document representations derived from these diverse encoders will further push the limits of zero-shot classification when combined with our proposed unsupervised contrastive pre-training procedure. And the second limitation is that results in the paper are on a single dataset, while we mitigate this to a large extent by creating 4 non-overlapping test splits. Results in more datasets might yield more useful insight. And the lack of datasets for this task is what makes this exploration difficult and might require creation of new resources.